Hello everybody, this is Dr. Christopher White, and in this video we're going to be looking at the relationship between surface waters and groundwater. So the first thing to remember is that we shouldn't think of groundwater and surface waters in isolation. They are in fact connected. So in the case of groundwater, we know it's going to flow down the slope of the water table, and this typically will follow topography. So the groundwater will flow from areas of higher topography to areas of lower topography. And it's not uncommon for these areas of lower topography to host bodies of water in the form of lakes and rivers. And so this means that for a lot of rivers and lakes, a portion of the water within them is going to be contributed by groundwater. We also have a situation where the water table will intersect the surface of the earth, and in those instances, of course, we will end up with a spring. So the first thing I'm going to look at is how does water move between the surface and the subsurface? So due to the constant outflow of groundwater, consistent replenishment is essential. And so this process is called groundwater recharge. So if we look at our diagram here, we clearly have a situation where we have our saturated zone down here. Here is our water table, and we can see that it's intersecting the surface of the earth right here. And so we're going to end up forming springs along this point where the water table is intersecting the surface. Now, obviously, this means that water is leaving the groundwater and flowing onto the surface. And so that water needs to be replaced. And so it's being replaced as new water infiltrates from higher up. So this is the groundwater recharge. The precipitation is coming down, infiltrating, and replacing the water that's being lost through the springs. Now, as long as the topography does not intersect the water table, the groundwater will remain below the surface and will flow towards lower elevations. Now, in the case of that diagram, once again, we have a situation where the surface is intersecting the water table, but if that doesn't happen, the water table will just keep flowing, the groundwater will keep flowing along with the slope of the water table. Now, where the water table does intersect the surface, it will produce a spring, and that spring can feed lakes and rivers. So springs are typically located along topographic lows or on steep slopes. So in terms of the location of springs, if you think about it, most of the time the water table is going to be approaching the surface as you move towards some kind of topographic low. So in this case, you can see the topographic low is represented by this lake or river right here. And you can see that as you move towards this topographic low, the distance, so the thickness of the unsaturated zone is getting smaller and smaller. And of course, by the time you reach this point, you're in a situation where the unsaturated zone is no longer present and the water table intersects the surface. The other possibility is that maybe the slope is so steep that the water table cannot adjust its slope to account for it. So imagine, if you will, that the slope of this hill is actually straight down, very, very steep. Now, you would normally expect the water table would dip down as well following the steep slope. However, that's not always possible. So if you do have a very steep slope, it's possible that that will allow the water table to intersect the surface. And once again, you will end up forming a spring. Now, springs can also form where you have faults which intersect the surface. So the fault itself may not be the aquifer. So there may be another aquifer nearby, which is the main aquifer, which contains the porous rocks through which the groundwater is moving. However, if the fault happens to intersect that aquifer, the fault will act as a conduit, a point of weakness through which the groundwater will flow. And so in that situation, you don't have to worry about the water table intersecting the Earth's surface. In the case of the fault is what's doing the channeling and moving that water towards the surface where it will form a spring. You can also have a situation where your groundwater is flowing along your aquifer, and your aquifer happens to intersect an impermeable layer of rock, so let's say a granite. And so your aquifer, essentially your layer of porous rock, just stops when it hits the granite. And so The problem is, well, what's going to happen? Because you have water which is flowing down your aquifer, and that water needs to go somewhere, but it can't because there's the impermeable rock in front of it. In that situation, the groundwater is forced to start rising up along the contact between the aquifer and the impermeable layer of rock, and this too can force the groundwater to the surface, resulting in a spring. So in the case of faults and in the case of impermeable barriers, it's not the water table intersecting the surface, it's another feature which is helping to channel that groundwater flow until it reaches the surface to form a spring. Now, we can also have springs that form from groundwater that is heated due to shallow magma. Of course, the Yellowstone would be a good example of that. And these will produce warm or hot springs. So the next thing to think about is, how are lakes and wetlands related to groundwater? So a significant proportion of lakes occur where topographic lows intersect the water table. So if we look at our diagram here, we can see that we have our water table coming down, we have the surface coming down, and we can see the two intersecting right here, resulting in the formation of this lake. As we also come down here, we can see once again, we have our valley bottom where the water table intersects the surface, and in this case, we have a lake or a river. So a significant portion of lakes occur where these topographic lows intersect the water table, and so that means the groundwater will be contributing to the water contained within the lake. Now, some lakes will form in what are referred to as areas which are perched above the water table, and these are referred to as perched lakes. So in the case of our diagram, we can see a perched lake over here. So you can see that the water table is all the way down here, but the perched lake is sitting directly above it, above this unsaturated zone. Now, because this material is porous, it's permeable, water is going to be leaving the lake, infiltrating down through the unsaturated zone and entering the saturated zone and becoming groundwater. So straight away you're thinking to yourself, well, hold on, that means the lake's going to empty out. So why is the lake full of water? So in the case of perch lakes, they need to have a constant supply of water, which is either being supplied by a river or it's being supplied by melting ice. And so the majority of perch lakes are going to be found in elevated terrain, typically near some kind of large source of water. A melting glacier would be a really good example of one. And this means that there is a constant flow of surface water into the lake, and that water can then infiltrate from the lake down into the groundwater. But the lake itself will persist because it has this constant replenishment of new water coming in. Now, in the case of wetlands, the situation is slightly different. We have a situation where water is entering an area. So let's say we have a river bringing water down, or maybe we just have an area which has very high levels of precipitation. Now, in this particular instance, what we have is we have this grey layer right here. It might be a bit difficult to see, but it's right there. And this grey layer is an impermeable layer of sediment or rock, so the water cannot move through it. You will also notice that the terrain is relatively horizontal, so there's no slope, there's no gradient down which the water naturally wants to flow. And so you end up with a situation where you have relatively horizontal terrain combined with an impermeable layer of rock and sediment. Well, in that case, that water can't go anywhere, it's just got to sit on the surface. And so in that situation, what's going to happen is your soil horizon is going to get saturated, and you're going to end up with wetlands. And these wetlands are going to be perched above the water table. So in terms of lakes, as previously mentioned, a lot of lakes will have some input from groundwater, and that's typically because lakes form in topographic lows, and so you are likely to have the water table intersecting the surface at those locations. Now, the nice thing about these lakes which are fed from groundwater flow is that they will persist even under dry conditions. So the classic example of this is a desert oasis, where you have an aquifer which intersects the surface, forming a small lake in the middle of your desert. And of course, In terms of surface water, there's no surface water feeding the lake because you're in the middle of a desert. So the water therefore must be coming from groundwater. So there must be an aquifer which is pushing water out to produce the oasis. Now, in terms of lakes, as previously mentioned, lakes will form in valley bottoms and topographic lows. So the size of the lake that forms will vary depending on the rate of flow, and this can be the rate of flow of groundwater or the rate of flow of surface water. The more water that comes in, the bigger your lake is going to be. Lakes are typically in equilibrium with the adjacent groundwater. So typically, you have a combination of water coming in from groundwater, water coming in from rivers, and of course you're then losing water through evaporation. You're losing some water because it will leave the lake and infiltrate the surrounding soil and rocks, and so you will eventually reach a point of equilibrium. Now, this equilibrium might change throughout the year. So during the winter months, for instance, when it might be wetter, the equilibrium will shift. And of course, then the equilibrium will change during the summer months when things are drier. So in terms of streams, how do they interact with the water table? So in this case, you can see we have two rivers. And in both instances, these rivers are interacting with the water table, but in different ways. Now, streams or rivers result from the balance between water inflows from surface runoff and inputs or losses to groundwater. So what does that actually mean? Well, most rivers are dominated by water that is inflowing, coming into them from their tributaries. So their tributaries are transporting water and then it's entering a single channel, which is our river. So that water will then flow along the surface. However, the water within the river doesn't always stay in there. Sometimes some of that water will leave the river. Maybe the river passes over an area where you have a very porous set of sediments and the water table is quite low. In that situation, you will have water actually leave the river and enter the underlying sediments and infiltrate down towards the water table. In contrast, if the water table is high enough so that it intersects the river, you may have water leaving the groundwater and entering into the river, so contributing to the volume of water. So rivers can either lose or gain water to groundwater. So, okay. So in terms of streams, they will cut valleys which are both laterally and vertically. So the river goes from side to side and it will also be cutting down. And this will sometimes result in a topographic low that will intersect the water table. So in that instance where you have a topographic low that intersects the water table, you're going to have water coming out from the groundwater and entering the stream. And this is referred to as a gaining or gaining stream because it is gaining water from the groundwater. And these are the types of streams that will keep flowing even in dry conditions. So, for instance, in the summer in Texas, it gets very, very hot, very, very dry. And so you will typically see some rivers will start to shrink. But even when it's at its hottest and driest, some rivers will still keep flowing. And that's because they are gaining streams. They are gaining water from groundwater. And that's what you're seeing run down the river channel. Now, that is shown by this diagram right here. We can see here is our river valley. And the river valley is clearly intersecting the water table right here and right here. And so this means that the flow of groundwater is going to come out onto the surface and contribute to our river. Now, there is going to be a reverse situation though, and this is going to occur when you have a stream that passes over an area consisting of permeable material. And this permeable material is located above the water table. So it's part of the unsaturated zone. So in that situation, you are going to have water leaving your river. And so this means your river is going to be a losing or losing stream. So in this lower diagram, you can see we have a situation where our water table over here and here is much lower compared to our surface. You can see there's quite a thick unsaturated zone there. Now, in the case of our river, it's coming along and it's moving across this region of unsaturated permeable material. And so what's happening is water is going to leave our river and enter the unsaturated zone. Now you can see that the water table actually bends up, approaching the river, and that's due to the water leaving the river to enter the groundwater. And so this is an example of a losing stream. So as mentioned, the river is losing water to the groundwater. So if the flow of water eventually slows down, the river will dry up because the water within it will be percolating, will be infiltrating down into the unsaturated zone. So as mentioned, gaining streams will often persist during drought conditions because they are constantly being fed by this stream of groundwater. Now, there is one more situation we need to talk about when it comes to streams and groundwater, and this occurs when you have a river moving across impermeable material and then moving over permeable material. So this is commonly seen in elevated terrain, so in mountain ranges. So if you imagine you have your river in your mountain range and the river is flowing down your mountain, which let's say is made of granite, and it doesn't have any fractures, the granite's just impermeable. So the water can't go anywhere. So all it can do is just flow across the surface as runoff. And so your water, forms a river, and that river cuts down your mountain, and eventually, as you move towards the bottom of your mountain, there's a transition. You move from the impermeable granite to a permeable sediment. And so in that situation, what can happen is instead of the river continuing down off the mountain and over the layer of sediment, in some cases, what you will see is you will simply see the river just disappears at the interface between the impermeable rock and the permeable rock or sediment. And so in that situation, your stream may just disappear completely, or it may lose a lot of water and it may become considerably shallower because the stream has got less water in it. All right. Thank you for watching, everybody.